Hello everyone, welcome to Data Science and Algorithms. My name is Sixtus Dakura. In the last video, we had a look at how this course is going to be run over the next few weeks. So in this video, we are going to take an in-depth look at the data science process as an introduction. So the data science process starts with a question, and the question could come from business. So let's say we could have a business problem that we need to solve. For example, if I'm running an e-commerce website, then when people visit my site, I'll probably like them to purchase an item. So the question I ask myself is, how do I increase my conversion rate? That question could also come from academia in the form of a research question, or it could also even just be a fan thought. Let's say if I'm a fan of football, then you might be interested in predicting the chance that a particular team will win the next World Cup. So in this case, you gather some data, just build some cool models to play with. So that is how the data science process starts. It starts with a question either from business, from research, or just a fan thought. So once you have the question, the next thing you want to do is want to solve this question or provide answers to this question using data. So we go ahead and gather data, and data could come from various sources. It could come from databases. Databases could be proprietary or open source. Throughout this course, one data services that we'll be using is DataWorld. It allows us to access government data or sometimes even private industry data as well. We could also get data from other repositories. For example, we can get data from GitHub or even data science competition websites like Kaggle. And then we could also get data from APIs. In this course, we learn how to use Python to scrape data from websites to build some cool models. So once we get our data, chances are that it's not always in the form that we can easily build our models with. So we have to apply some pre-processing to our data. That is the next stage of the data science process. So once you have the data, chances are that it contains missing values, it contains duplicates, or the data types are inconsistent. So what we do then is to try to clean this data. And cleaning could include probably removing the missing values or imputing those missing values. We will learn how to deal with duplicates and how to convert data types so that they are consistent across our data set. And then an optional step is probably to transform our data, right? For example, if my data is in the millions, the data points are in the millions, and I would like to work with data that are between 0 and 1, then I could apply some transformation to that my data, and then my data points will be between like the range that I would like to work with. So it's an optional step, but can be a convenient step depending on your use case and then your application. So once we have our data, we clean it and probably apply transformation. The next step in the data science process is to try to generate more features to improve our model's accuracy. So this is where we feature engineer. So for example, let's say if I want to predict someone's GPA, then probably I want to predict that GPA using their age and then the number of hours that they study. Maybe these two features or these two variables will be enough to predict someone's GPA. But obviously, there are other factors that affect someone's GPA, right? So in this case, I could decide to, okay, let me use these two features that I already have to generate a third feature to improve my model's accuracy. Or I could look to other external sources that will help me like generate more features to help improve my model. So this is where feature generation comes in. So in Xsense, this is where your imagination comes in too. So you could use existing features or data from other sources, as I said, to create new features. Then once we created features, we want to use the most relevant ones in building our model. So we do feature selection. So once we've feature engineered and selected our features, then we move straight on to building our model. That's the next stage of the data science process. And here, this is where we apply all the algorithms that we are going to learn to build our models and evaluate the results. There are various stages that we go through in the data modeling process, and we look at that in this course. So once we build our model and then we have our results, the next step, which is also quite important, is to communicate or present our results to a given body. For example, if I'm working in industry, then once I build my model, probably and get results, I'll have to explain that to my supervisor or present that to a group. All right. Or even if I'm in academia, then I might have to present that to my supervisor. Even if it's just a fun project, I might want to share the results with my friends. So communicating and presenting your results is an important part or important step of the data science process. Then I like to say that like a model is a living thing, so we have to keep on updating it and keep on feeding it with better and improved data. So once we build our model, once new data comes in, we have to update our model. So we deploy and then continuously maintain our model. So this is how the data science process goes, right? We start with a question, we gather data, we clean that data, we feature engineer, then we build a model, present or communicate our results, and then we deploy that model and maintain it over time, right? So that out of the way, what are the use cases of this knowledge, right? Is used in financial services. For example, if you are a data scientist at a bank, what your work might be focused on is probably developing models to help detect, let's say, fraud and financial transactions. It's also used in general research, mostly in cancer research and sometimes in just basic academia research, like let's say when a cluster cells based on genes expressions across the cells. And then also used in ads and recommendations. A typical use case is in Google. They make heavy use of data science tools to build their ad engine. And more advanced logistics and delivery services also make use of data science, right? So either you work in financial services, general research, ad and recommendation, logistic and delivery services, all of this comes with some fancy titles, right? And what I did, one that comes to mind is a data engineer, right? So a data engineer basically is like a professional who prepared the big data infrastructure to be analyzed by data scientists. So in some sense, they are like software engineers who design and probably build and integrate that data from various sources and manage that big data like infrastructure of, let's say, an organization. So if you're a data analyst, you might not have to deal with the nitty-gritty of compiling data and making sure like it's in a form that is accessible. That is the work of a data engineer. Another fancy title that comes up is a deep learning engineer. Um, and deep learning engineers basically try to restructure the usual algorithms that we know into layers to create what they call artificial neural networks that can learn and make intelligent decisions on its own. So the models that they build are somehow termed as deep models, and that's where the name came from, deep learning engineer. Another one that comes up that probably a lot of you know is the machine learning engineer. So machine learning engineer is quite similar to a deep learning engineer. Aside that, they basically use the common algorithms that we all know to parse data. They learn from that data and make informed decisions based on that. And then the last one is the data analyst, right? So data analyst probably is someone who collects, processes, and performs some statistical analysis of data. He or she can probably translate numbers and data into plain English in order to help organizations and companies understand how to make better business decisions. So you see, across all the definitions, there are some similarities, but depends on the organization you're working in, your role might be very specific. So these are all the titles that people have in industry. The most common one, let me put it that way. And so once you're working, you probably might bear one of these titles. Okay. So that is all I have for today, guys. Thank you, and I'll see you in the next video.